Today we're going to focus on how to create a drawing that has a geometric shape, and it's got some interesting curves and objects that are tangent, and so it's not as simple as a basic linear drawing. So we're going to create the object. As you can see, I put a raster image up in AutoCAD, so you're able to follow along and see what we're going to create. So to give you a quick rundown on how it's going to be done is we're going to first start out by creating all the center lines, and from the center lines we're then going to create the shape of the object. And at the end of the video we're going to show you how to put the object on a layout, make it to scale, and then it'll be ready to go to be sent to your printer, because once it's on the layout we print it 1-to-1 because you've done all the scaling in the layout itself. So we're going to do a short component on layouts also as part of this geometric construction video. So let's get started. As you know, we've got our 4 setup steps that we always do on all of our drawings, and the process is going to start off with the big letter A in units under drawing utilities. And I look again, and this one happens to have 3 decimal places as the basis for all the drawing. So we want to change our precision in decimal to 3 decimal places. Object snap and polar tracking should already be set from our previous utilization, and we can do a quick check here. Here's object snap. It's got our endpoint, midpoint, center, intersection, extension, perpendicular. Polar tracking is set to a 5-degree angle. We're not going to worry too much about angles on this because the lines that are being shown are tangent. And then finally we have layer properties, and we want to set up our standard layers for a shape drawing, which is an object layer and a center line layer, a hidden line layer, and a dimension layer. And again, we may not be using all these layers. In this particular drawing, we'll be using the object layer, so we're going to set the line weight to 0.5 millimeters. And the reason behind that is that's the diameter of your lead in the mechanical pencils that you've been using. So 0.5, 0.7, that kind of thing. Center, we're going to have to set up continuous line types. We're going to have to go to center line types and select the center line. And this one may be too big, so we might actually have to go and not just do center, but we might have to actually go down here and choose center 2, which is half the scale. There is a command called line type scale that we can use to scale our center lines, but if you know that it's going to be a smaller drawing, in this case it is, it's only about 6 inches in size, a little bit bigger than 6. Again, center 2 may work better. Hidden lines would be the same way. We're not going to necessarily set that up. And then dimensions, if we put some dimensions in, we'll make them magenta today. And so we've got our layers now set up and ready to roll. We'll close the layer dialog and get rolling. So the first thing we have to do is start with our center line. And it doesn't matter where we start with our center line, because we just need to basically pick a spot on our drawing environment. And so I'm going to go ahead and create a line and repeat this line, and by creating a intersection of 2. And so we'll say that that's this location over here on the left hand side. So we need to offset the horizontal down 1.179. Excuse me, 1.779. I said 1.1. And so there is a great command called offset. And the offset command, it's not one of the key 12 that are, excuse me, the key 9 that are listed there, but it is part of the 12 package here under the erase area. So we pick offset. We type in the distance, which is 1.779, and hit the enter key. And we then select the object, which in case is this line, and we pick below. And so that line is now exactly the correct distance. 3.258 is the vertical line. So we're going to have to pick the offset command again, type in the new distance, 3.258, hit the enter key, and then offset this to the right. Well, over here is going to be the intersection of that particular circle. To make that work, we're going to need to extend these lines. So to do that, there is a great tool called grips. And so if I just go ahead and pick on top of the object, and I get 3 blue boxes. If I pick a blue box on the end, I'm able to extend it or contract it. And so that's the idea, is I can contract it, contract one end, extend the other. If I do more than one, as long as I don't do an editing command, I can do the extend and pull around like we're doing. And to get out of the grips, we hit the escape on the escape key. Wow, that was weird. Hit the escape key on the keyboard. And we have one more location to locate, 2.630 and 1.649. And again, the whole key is that you want to start every drawing with center lines, because those are typically the basis of all your drawings. So 1.649. And 2.630. And again, they don't touch, so we're going to have to use the extend grips capability to extend these out and shorten them so they're in the right locations. And this just makes it an easy, clean drawing environment. Okay, so typically what I'll do is I'll work from outside in as opposed to inside out. I know that a lot of people love doing the circles first because they're easy. But on the other hand, in some cases the circles are important because then you can use the center points of those circles. But in this case, we're going to be drawing circles to get the outer shape anyways on these position locations. So the first one I'm going to draw is going to be over here on the left. It's a radius of 0.889. Okay, we're going to create the circle over here on the left-hand side, and to do that we're going to use the circle command. And as you can see, there's a variety of different tools that are under the circle command. We're going to use the center radius because we're given the radius value. And so we pick center radius, and you'll notice I get the midpoint, but that's not the correct location. The midpoint's slightly off, but I actually want to get the intersection of the two lines. And so I'm going to move it around and see if I can get that exact intersection to show up. And if I can't, I'm going to magnify it and make sure that I can get that intersection. That happens to be the perpendicular location, and so I want to make sure I get the intersection. And that is the intersection, by the way, the perpendicular bisector there. And so 0.889 is the radius. And I've just created the circle, and that circle, unfortunately, is done on the wrong layer. So now I've got to change that layer from the centerline layer to an object. So I'm going to select it and put that grip tool back on it and come up here to the layers and switch it over to the object layer. And again, as we've talked before, we never want to draw on the 0 layer. We always want to create separate layers for each of our objects and each of our entity styles. And so now that we've got the object correctly positioned on the layer, we need to go back and change our center layer back to the object layer and make that the current working layer itself. So the second thing that we're going to do is we're going to create the second circle here, and this one happens to be a radius of 1.067. So we're going to go ahead and create the circle center radius again, find that intersection, and there it is, and 1.067. And the third one is a 0.711. Same scenario. We find the intersection, 0.711. So now I've got the 3 core outer circle components. And so now I've got a arc in here, and then I've got a couple of lines here. So we're going to show you how to do the lines first, and then we'll deal with this arc on the end. So to draw the lines that are connected to the circles, we don't know exactly where that connection point is. It's called a tangent point. And so it is a perpendicular position based on the angle between the two circles, the larger and the smaller circle. So the easiest way to do this, and if you remember in our object snap, we don't turn on tangent. And because we use the center tool, because that's much more useful than the tangent tool. So how do we get tangents to appear? Well, the easiest way to get tangents to appear is to hit the line command. So we start the line command. We hold the shift key on the keyboard. The shift key is pressed and held down. You can see the little icon there if I hold it. And then right mouse click. Now if you hold the shift down too long, then another pop-up occurs. But it's just hold the shift down, right mouse click, and you'll get a pop-up object snap menu. And this is a one-time use object snap. So if we want to override all the other object snaps and say, I want to use the tangent object snap, this is the way to do that. It's just shift right mouse button on your mouse and you choose tangent. And you'll notice that I get a new icon. That's the circle with the bar line on top. And so I'm going to pick this quadrant because I know that that line is going to start somewhere on this arc. I'm going to do it again, shift right mouse button and pick tangent because I need to pick the tangent twice. If I just pick another point on the circle, we don't know if it exactly is the tangent location. So we have to do it 2 times and then hit the enter key or the escape key to stop the line command. And so what has happened is I've created a line that is tangent from one circle and tangent to the other circle. And so we have to do this again on this side. So it's line, shift, right mouse button, tangent, pick the quadrant area, shift, right mouse button, tangent, select the quadrant, and then stop the line command. Wow. So that was a fairly difficult structure with the tangent, but the process is actually easy once you know the shift right mouse button tool. The last step is drawing in an arc here between these two circles. And so we see that we've got an arc command here, but there's so many different options with the arc. So what do we know about the arc? Well, we know the radius of the arc is 2.845. So we could do start end radius, and that could work. So the question though is where's the start and the end point on the circles? Well, it is on the tangent locations because it is a tangent circle or a tangent radius. So we can try using the pop-up tangent with the start end radius and see what happens. So we're going to pick start end radius. We're going to hold the shift and right mouse button down and pick tangent, and I'll pick the first circle. I'm trying to pick this area. Notice how it's different. It's trying to pick it only in one spot up here at the top. And the end point is going to be a shift right mouse button tangent. And again, it's only locking in a single location. So now our radius distance is 2.845. So I type in 2.845 and hit the enter key. Oh, that didn't go as well as I would have hoped, right? Because that's what most people would do is they go to the arc command. And the arc command has start end radius, and we use tangents just like we did with the lines. Makes perfect sense, except it never works. Because the tangency positions, if you recognize that, it was a single position location. And so we're going to have to delete the arc here. So we just go up and pick it, grip it, right mouse click, and choose erase. The better tool to use is actually under circle, because sometimes you have to create the circle to create the arc. And we have a tangent radius. So that's going to pick 2 tangency locations. We type in the radius of the circle, and there it is. It'll create the circle for us. So we're going to pick a tangent. Notice the difference in tangent. It's flexible. It moves. The other one was stationary, and that was a clue that it wasn't going to work right. Tangent 2.845. There it is. And it automatically positioned the circle properly. So again, circle's fairly big, 2.845 radius, which is doubled for the diameter. So it's almost a 6-inch diameter circle. Okay, so now we've got to clean up the drawing to make it look like this, which means we need to get rid of these internal arcs on these circles and this external arc on the big circle. And so we use a tool called trim. And so the trim tool is a tool that allows us to cut objects back. It's a two-step process though. The first step is that we have to pick the locations that we're going to use to be cutting edges. So we're going to do a single demonstration here, and then we're going to do a multiple selection and finish out the drawing. So the single selection is I'm going to trim the upper part of the arc. So the cutting edge is actually the two circles, because the bigger arc, in this case the large circle, touches the two smaller circles, and so those happen to be the cutting edges. Once you've selected the objects of the cutting edges, and here's the key component, on the trim, on the extend, on the rotate, on the move, on the copy commands that we'll all be looking at, you have to hit the enter key after selecting objects. Whether it's the keyboard or right mouse click and hit enter, one or the other, we've got to move to the next step, because that's what happens is we are finished selecting our cutting edge, we have to hit the enter key, whether it's on the keyboard or a right mouse click, to move to the step. And now you can see it says select object to trim. Well, one of the cool things that AutoCAD does now is it highlights what's going to be trimmed. And so you can actually see that it's going to remove the top part of that arc, which is exactly what we want it to do. We could have trimmed the bottom part instead, and then we would have had a big top part of the arc on here. When we're finished with the trim command, again, we can hit the escape key, or we can right mouse click and choose enter, either way. So now we have to do the same thing with these internal circles. And so the cutting edges on the internal circles are going to be the straight lines, the two tangent lines, because those are cutting edges. And it's also the arc, because that arc and the line cuts this part of the circle. The arc and the line cuts this part of the circle. So I have to select all three objects as cutting edges. Right mouse click, and I can select the internal parts of the circles to clean it up. So the last step is to actually draw the three circles, and you can see the notation 3x.889, which indicates that there are three circles, all of the same diameter. And that's what the little circle slash indicates, is a diameter symbol. So we're going to use the circle command, but this time, since I know the diameter, I'm going to choose center diameter. So now we've used three different circle commands: tangent, tangent radius, and center diameter. So again, intersection location, and the diameter is 0.889, and we hit the enter key. The nice thing is that if I go up and pick the circle command again, it's going to remember by just hitting enter the last diameter I typed in. So I picked the intersection. It knows that the diameter, if you take a look down here on the bottom on the command prompt line, it already has 0.889 filled in down here on the bottom. And so all I have to do is hit the enter key on the keyboard, and it will create the circle. Okay, so now one of the questions that pops up a lot is, well, how do I make my drawing look pretty? You got really pretty center marks and dimension placements and so forth, and center lines. And that takes a little bit of effort, and the initial center lines that you create may not look very pretty because they're based on the distance that you're drawing the line and the breaks that occur. So if you want to make really pretty center marks, there is some tools under the annotate to make that happen. There is a center mark tool. So let me show you the quick way to accomplish that. We're going to go back to the Home tab, and the first thing we're going to do is delete all of the center lines that we used to create the drawing. And the reason being is that we need to delete these lines to create the center mark positions, but we need to create the center marks on the center layer. So not only do I delete the original center lines, I then move to the center layer, go to the Annotate tab, and then pick Center Mark. Now the center mark will create a really nice looking clean center position, but you want to select the outermost arc for that to occur, or the outermost circle. So in this case, the center mark, we want it to extend beyond the drawing environment. So because again, dimensions will connect on to the ends of the center marks. And if you wanted to, you could then put dimensions on the drawing by changing the layer again and adding dimensions. So we go to Home, switch the layer around to the dimension layer, back to Annotate. I typically like to use the linear dimension as opposed to the creates all different types of dimensions. This gives me a little bit more control of exactly what I'm shooting for. So the process is, if we wanted to do a similar dimensioning pattern, it will come up and give us a similar dimensioning pattern. And you might be saying, wow, but there's 4 decimal places in the dimension and we only set 3 in the units. Well, there is a total, if you remember, number 5 and 6 deal with dimension style and text style. And then the last one's layouts. So dimension style and text style the dimension style controls how many decimal places there are. As I've shown you in other videos, you can grip it, right mouse click, and change the precision to the number of decimal places you need. And that's the fast way to do it without having to set up a formal dimension style. We'll be setting up a dimension style in one of the future videos, so that way you'll be able to see exactly how to edit and work with dimensions in that way. So again, it's all about selection of position, and we'll grip it and right mouse click. So how do I get a dimension to show up for the circle? And so we've got 3 at 0.889. So we use what is known as a multi-leader. And so the multi-leader, we select the object, and in this case, I could use the radius dimension too, which is another option, because under linear there is an option for radius, and that may actually work better, is to select the radius or the diameter. In this case, the diameter for the circle, radius for the arc. If I select the diameter, I get the diameter 0.889, but then I still have to edit this to put in the 3x, because it's nice having that 3 times so I don't have to put 3 separate dimensions in. So I can double click. So I grip it, and then I double click on the grip, and then it should come up and pop up with an edit window. And so that edit window, I can change, and I use the arrow keys on my keyboard to make sure that the flashing icon is in the very front. You can kind of see where the icon is here. And then I'll type in 3 space x capital space 0.889, and then I can hit the enter key, or just click off on the screen actually is the easiest, and it updates the dimension for that. Now I can still change the precision, because the precision, well, excuse me, I can't change the precision because it is a now edited dimension. So the way to change that precision would be, again, to double click, this time arrow over to the far end, and then we would have to edit that number or edit that value to make it slightly different. Uh-oh, now I've really changed this. So we can change the shape of that dimension and so forth. So this would have to be edited within the dimension style to get the proper number of decimal places. All right. The last thing I wanted to show you is how to put this on a layout. And so that way the drawing can be printed or create a PDF of that drawing for output. So under layout number, and we have 2 layouts, 1 and 2. Makes no difference which one you choose. We're going to choose layout 1. And there is a video specifically on how to use layouts. Let me go ahead and hit the escape key to get out of any commands. I'll choose layout 1. And layout 1 is our drawing surface. And so you can see that it has both the raster image and the vector image. So I might end up having to delete the raster image to get the proper scaling of the drawing. And to do that, I would actually just go back to the model and make an edit. So the quick process on doing layouts. Layouts are the actual printed drawing sheet. So you actually want to make sure that the paper size that you're working with is the paper size you're printing on. This one happens to be 8.5 by 11, and so it's a small scale printing environment. And to change the layout printing information, you right mouse click on layout, and page setup manager will change the information for the paper, and we want to modify it because right now it's 8.5 by 11. And so if we wanted to do B size, which is 11 by 17 or 12 by 18, I actually need to come in and change the paper size. And the paper size may be based on the plotter that you select. And so this one, since I have no plotter selected, it allows me to change it to any size. And so I can go to ANSI B, and it's 11 by 17. And then if I choose OK, and again, we don't want to change any of the scaling or any of the other information. We're just changing the paper size here. It changes the sheet to an 11 by 17 piece of paper. Makes it pretty easy. This also shows you in the dotted line, if you have a printer selected, it will show you the exact printable area. So, for example, this happens to be the default printable area for the printer. So the basic way to scale this up to make this full size on the sheet, we've got a couple of things going on. Number one, this pink outline of the object box. This happens to be, and if we go back to the Home tab, if we change from the dimension layer to, oh, we got a def points layer. We'll have to talk about that in a future video. That deals with dimensions. We can go back to objects. But in this case, the pink, which was when we created the layout on the dimension layer, I might want to switch this over from there to the object layer. And so now it's a dark line as opposed to the pink line. And this is called a viewport. And the viewport is actually the printable space. And so we need to expand the viewport out to the edges. And some actually go just outside of the scaled area. I mean, just outside. Why? Because the viewport will not print then. Those dark lines, if I hit the escape key, that viewport line will print unless you put it on a non-printing layer. And so you have to be aware that that viewport is a printable space. All right. So now we do the song Hokey Pokey, and hopefully you're familiar with it. If not, YouTube it. You'll see a bunch of people doing Hokey Pokey. But in the song, you left foot in, left foot out, left foot in, shake it all about. Well, the same thing has to happen here. We double click in, we double click out. If we double click in, we're able to move our drawing about. And the whole idea is that we're able to scale. Once we're inside this viewport, we can scale the drawing itself. And that scaling actually shows up in the lower right hand corner, and that lower right hand corner gives us the ability to choose what scale we want to work with. And so if we say 1 to 4, it improves the scaling, but it's still not good enough. We're going to have to go like a 1 to 8. Uh-oh, wrong direction. So we actually want to go 1 to 2. So this is called half scale. So it's half the original size. So if we were to measure the dimension, the physical dimension between those two, or this particular location, it'd actually be half the actual size. If we go 1 to 1, that's full size, and that would work if we were just printing the object without the raster image. And you can see how I kind of pushed the raster image off the screen. And so that's one of the neat things about layouts, is that I could have a lot of parts in my drawing, and I could have a lot of different layouts, and each layout highlight a different part within the single drawing environment. And I can print all the layouts together as a single PDF. So when you're printing, when you actually go to the printer and get that set up, now that we have our layout and it's set to 1 to 1, by the way, I just pressed and held the mouse wheel to shift the image around on the screen. That's called a pan, P-A-N. And the last step is to go to the printer. And so we're going to actually do a file and plot. And if we plot, what we're going to do is we're going to send it to a PDF file. And so Microsoft Print to PDF works really well. If you don't have other PDF printers, AutoCAD to PDF, web and mobile does work well, and general documentation. So there's all different types of PDF output because it's becoming one of the most common ways to output your work with this drawing. And so we know that the scale is right because we've set the scale inside the layout. All we have to do is just save it. And so when you hit the OK, it's going to ask you for a file name to save the AutoCAD high quality PDF print. We don't have to change any of the other plot settings within the environment because we've got all the scaling. The PDF options, though, do come into play. And so we want to make sure that the PDF options lines will overwrite each other, which is fine. Include layer information and any hyperlinks that you put in the drawing, so it's an actual usable PDF for your customer or instructor. And we'll work from there. What are we going to print? We're going to plot the layout itself. And so we can plot the layout or displays or other components. All right. And you pick the OK. It'll ask you for a name save, and you're all the way there. All right. Well, that should pretty much take care of how to create a basic geometric construction and how to get it into a layout to plot to PDF for you to create either a printed drawing by choosing a different printer or a PDF environment. Have a great day.